Previously on HVACR videos.
Evaporator right here, it's dripping out of here. We come back here and we can see standing water in the drain pan. But the problem is this drain goes over here and then is interconnected to their beer walk-in and their walk-in freezer. Well, we're gonna go into those right now and check to see if those are plugged up too. Since it's connected to two other walk-ins, what I did was came into the beer walk-in, made sure the drain wasn't backed up in here, and then also went into the freezer. It's not backed up in there. So the restriction is before it connects to these guys, and these guys are still draining properly. So that's kind of a good sign. Okay, now that we know that those aren't plugged up, we're gonna attempt to pull this union right here. We'll drain out the water into that pan, and then we'll try to see if there's just a clog in the pan right here or what it is. And try to stick my fingers. I don't feel anything. The coil feels really crusty. So let's try to drain this thing first. This is probably gonna make a mess. Probably just let it drain like that for a minute. It's only that pan right there, so it shouldn't be too bad. It's going right into that pan. So I'm gonna let it drain out and then we'll get in there, and I have some methods of blowing this out. So while I'm waiting for that to drain out, I wanna talk about something. So if you look at the bottom of this coil, you see this like these little bumps, these ridges. That is the pan corroding away. Trust me, do not try to wipe that stuff off. You rub hard enough and you'll rub right through the drain pan. This drain pan needs to be replaced. When you start to see these little dimples, it's the aluminum just corroding. So we'll definitely talk to them about that, but this is really old equipment too, so they'll probably just replace the equipment. All right, I shut off the coil. We've got the drain cleared. The other ones aren't backing up. It's all good. Now we're gonna get some Viper condenser coil, the aerosol cleaner on the back of this guy. I did a quick pre-rinse and got majority of the bulk big stuff off. Now we're gonna get some cleaner on it. This stuff blows my mind because when you spray it on, it pulls dirt out of the coil. It just baffles me how it does that. So I'll give it let it sit for a minute, then we'll give it a rinse. And again, I'd already kind of pre-cleaned it, but this will just get a little bit more of it off. All right, so this coil is all rotted out, but I got it cleaned a lot better than it was all the way through. But there's like holes in the coil. It's deteriorating. Like, it's pretty bad. You got to be careful too about using like really harsh chemicals on it because it'll disintegrate it even faster. We know this thing needs a drain pan. We know that the coil's rotted out, but we're not going to stop there. We're going to keep going. Jump onto the roof, check the equipment out, make sure everything's good up there. This equipment is beat down. It's R22. The condenser's a little bit dirty. Someone busted a fluorescent light bulb up here. But the condenser's a little bit dirty. It's not bad, but I got the hose right down that ladder, so I'm gonna drag it up here, just rinse off these condensers really quick, and then go from there. I don't think we're gonna have any other problems. They weren't complaining of temperature issues, just a water leak. And we're running a clear sight glass. Got a Sporlan seat all right there. I don't see a need to go any further than that. I don't see a need to put service gauges on this, but this whole unit is just trash. Yeah, cap's missing off of the suction service valve. Just beat down. So it is time to replace this equipment, so I'm gonna get all the information so we can do that and give the customer the right information. This customer orders their own equipment, so I just got to get box dimensions, voltages, existing information off of the existing equipment, and then we'll be able to size, or the customer will be able to size the proper equipment for this box.
This video is brought to you by Sporlan. Quality, integrity, and tradition.
Well, we're scheduled to do a walk-in cooler retrofit replacement today, where we changed the evaporator coil and the condenser, and we made sure they weren't getting any deliveries, but my gosh, they got a lot of kegs in here. Holy moly. They're gonna have to take those out. Apparently their beer walk-in's completely full too, because we're going into Super Bowl weekend, so they were overstocking. We're gonna have to take all this stuff out to be able to do the work we need to do. I feel like they could fit at least 4 more kegs in here, but seriously, there's no way they're gonna go through this much beer. I mean, I know it's Super Bowl weekend, but that's insane. Today, what we're doing is we're replacing the evaporator and the condenser. This is an old R22 system, and it's just time to replace it. It just has refrigerant leaks, and the customer didn't want to put any more money into it. It doesn't have any like 911 major issues. They're just very proactive. So, pretty much should be a cookie cutter. Will's over here and he's gonna pump this guy down, and then what we're gonna do is just shove the gauges inside. We'll have the crane lifted onto the ground, and then we'll recover the existing R22 that's in there down on the ground. That way we don't gotta bring the recovery machine and stuff up onto the roof. So that shouldn't be too difficult. So as soon as he gets that free, then we just break everything free, disconnect the electrical, and go from there. So this is my attic space. I'm not too worried about this. There's plenty of room to maneuver. That's my line set over there. It'll just come down over. We'll probably do more than likely a brand new line set soft. Just let it come down, rest on the top of the box, and then 90 down into the coil. Shouldn't be a problem there. Yeah, not too bad. We have a lot of the materials already with us for the most part, but we have a lot of hardware stores nearby if we need anything else. I'm pretty sure we'll need like bolts and things like that. Shouldn't be too big of a deal. Our new equipment right here. No big deal, just a Russell condenser. And then they have a evaporator coil right there. Cool. Pretty plain and simple. Shouldn't be, you know, it'll just be the normal stuff we got to deal with, but we do a lot of these, so it's starting to get pretty cookie cutter. But you never want to let your guard down, because when you do, that's when everything hits the fan, kind of a thing. But we got a whole crew here. Robert's out here unpacking equipment. I got Will on the roof pumping it down, getting the condenser disconnected. Got Leo inside pulling the evaporator down. And then obviously we'll send people to help when it's time to drop the evap and that kind of stuff. The crane should be here in like 15-20 minutes. Once we get past that part, it'll just be walking through all the steps and the motions and everything. Okay, condensed unit's moved in hopes that when the crane lifts the other unit, we could set it right where it's supposed to go. It's basically gonna be the same condensing unit. This is an old cold zone, which is Russell. And I think what we have is a Kramer, which is Russell too. It's just one of their other brands. So hopefully set it right there. The theory is that we're gonna change the whole line set. That's the plan, but we're not destroying anything until we kind of get everything set and figured out. wasn't supposed to rain today, but it's raining, so that kind of sucks. But we got the new unit set. It's about where it needs to go. We'll shift it around and stuff and put some spacers under it to level it out when we're done. We're gonna try to go inside, let this rain pass. I don't think it's gonna last too long, hopefully. And then we'll come back up here. Well, we got over here now. What I'm gonna do, we're gonna utilize the line set coming down. We're just gonna cut it here and then 90 that way and drop down, because the new line set has to move to the other side because the coil is opposite. Same with the electrical. But it's always nice when you get over here and there's a giant freaking cobweb and you wonder where the spider is to follow, because that's a pretty intense cobweb. Probably piss them off right now. They'll come running. Alright, well, hopefully it doesn't come and bug me, because I killed the cobweb so I don't get cut up in it, but fun stuff. Alright, now I need to get diving on getting this electrical pulled through and getting the line set cut. Alright, now we're drilling up the holes nice and slow. There we go, we're good. And then we're gonna bolt the bolts and then cut them off up here is the plan. So we're gonna do them all, and then we gotta drill the line set hole too. All right, we got these guys all done. We'll cut them off shorter in a little while. We use the existing refrigeration line hole for the electrical, which is fine, that's typical. And then now it's time to drill the line set hole, and it's gonna be hopefully right there. I had pre-drilled from downstairs where I want it to be, so that way I have room for the P-trap and everything. So got the hole saw built, put it on the drill, get that drilled. I have a guy downstairs and he's holding a box underneath it to catch all the junk that's gonna fall out too. Gotta be careful, these bolts sticking up now. You don't want to jam your leg into them. That won't feel good. It's inevitable you're gonna get dirty. All right, you down there? Yep. All right, we're going. Got our hole drilled, and it's offset. The actual coil refrigeration piping's over there, but it's that way so we can come down with a P-trap over, have a straight section of pipe for the sensing bulb, and then 90 into the coil. I always put them towards the middle, that way you got room for the P-trap. When you're doing these walk-in jobs, there's lots of up and down, so you try to be as efficient as possible bringing up what you need. So I got the line set up here. I just went in and rolled it out really straight so that way I can maneuver it how I need to. I bought more than enough. And then we have 3/8, a bender, the ratchet bender for the 5/8, my torches. We're gonna reduce from 7/8 to 5/8, so I got the fitting. So we're getting there, almost there. All right, I got it bent. It was a little tricky, but I got it bent. We'll slide insulation on it last. This right here is gonna get swaged, so I just cleaned it, got the swaging tool. We're gonna do that real quick. You gotta be careful when you're using the swaging tool on the small stuff because it'll crack the fitting. So you have to stop halfway in between, release it, rotate it, then start again. That's one thing that I really wish NAVAC would fix, but I talked to them and they have no plans to. So just one of those things we gotta do. welding. What's that?
I need put 3/4 pipe and a union and some solder. Can I run out Google and get it?
Yeah, here, go for it.
Okay.
All right, dude.
You need anything else?
Not at the moment.
Alright, I'll hurry.
Thank you. Alright, that was a bit tricky because I'm blind on that side, so put a little extra solder, but it should be good. And we got the nitro flowing through on top, so. Alright, I'm gonna just inspect the braze joints, slide the insulation over it, and then for the most part be done up here. We still got to spray foam and cut the bolts, but we're getting closer. Alright, we got it all welded or soldered together. We're gonna do the insulation and the sensing bulb for the TXV real quick, and then once we do that, we'll button everything up, tape it up, foam the holes and all that stuff. So we're almost there. Didn't blow up when we turned on the power, so that's a plus. It's in low speed until the temp control calls, which it'll take a second. Then they should go up to high speed. We're done with the brazing and everything. Everything's there. I just need to tape up the insulation. We got a nice clean run. And that's why I like to do those P-traps right there, so that way it's in the middle of the coil, and then you have a nice straight spot for the sensing bulb. If you put the P-trap right out of the coil, then there's nowhere to strap the sensing bulb. So we're just waiting for this guy to click in, and we just turned on high speed, so we're wired correctly. I heard the solenoid valve kick in, so that's good. I'm gonna start cleaning up my messes. Leo's finishing up the drain, and then I'll go check on Will on the roof and see how he's doing with the condensing unit. All right, Will's kicking ass up here, so we're all brazed up. He's getting ready to do an evacuation. We'll let the insulation go, slide back and over. So yeah, not too bad at all. Looking good, and this is not pre-charged, so we got to open it up and we'll put some 448A in it and figure out the flooded charge now. So we needed some insulation that we didn't have, because our initial plan was we were going to change the whole line set, but we decided we didn't have to, but we had to put new insulation on. And there's like a residential supply house that I don't use called AC Pro over here. That's a bit annoying that they put their damn name on the insulation. That's like, I won't be buying from them again for that reason. That's stupid. I don't, whatever, but it'll be fine. But so we're just pulling the evacuation. We got the gas ballast open right now. We're doing a 1 hose pull, and we've got the vacuum gauge on the other end of the system. So looking good so far. Now our model number is an 0150E4S, and it says for 448A, 0150E4S is 3.8 pounds of extra refrigerant. So we need to clear the sight glass above the bypass pressure and add 3.8 pounds of refrigerant to compensate for the proper flooded charge. Now, we could calculate it ourselves using Sportland's 90-30-1, which is essentially what was done here, but it was already done for us. So all you need to do is find the information, 0150E4S 3.8. It also has another one that's just for a different model number, an O or an H, but it's the same thing. 50E4S, 3.8 pounds. So 3.8 pounds, we'll write that down. That is the flooded charge after you clear the sight glass, again, above the bypass pressure. I ended up moving a few things around because I ended up putting another hose on it just because it was dragging. But we're in decay right now. Solenoid valves open downstairs. We're getting ready to charge it. I've already purged high side, purged low side. I haven't opened either of them. So we'll go ahead and start getting ready right now to charge it up. All right, when I charge these systems up, what I do is I usually front seat the receiver all the way, okay? And then I'm dumping gas into the receiver, but it's not allowing it to leave. I'm gonna put about 4 pounds in there. We're currently at about 2 pounds. Put about 4 or 5 pounds. That'll pretty much be close to what the total charge is, I'm estimating, you know, before the flooded charge, basically. Then I'll release it via the king valve, let it go through the system, we'll test the compressor, and then we'll finish charging the rest of the way. We are running now. We did have to reverse the phases on the compressor because it was running backwards, but we're good to go now. We're gonna let it run for a few minutes. We've currently got about 6 pounds of gas in it. We're gonna wait. And then we need to get our head pressure above the bypass pressure though, to make sure it's got enough gas. It looks like it's starting to flash, but what we'll do is we'll block off the condenser, get the head pressure up higher, and then as long as we go above the bypass pressure, which on this guy is probably 150, 148, so it's 150. So anything above 150, which we're at right now, so that's fine. So we are above the bypass pressure, and we are flashing in the sight glass. So now what we need to do is clear the sight glass maintaining the head pressure above the bypass pressure of 150. And then after the sight glass clears, then we add the extra 3.8 pounds of refrigerant, and we will have enough refrigerant for when the head pressure control valve does bypass. But we want to be slow about it. That expansion valve is wide open right now. We want to let it kind of cool the box down when we're going to slowly charge this thing. All right, I'm going to call that clear. There's a little bit of movement in there, but this is one of the blends with a high glide, so you tend to see a few bubbles every once in a while. So at this point, we now need to add 3.8 pounds. Now, I'm going to change my units because if we go right there, actually we need to mark this. So far we put in 7 pounds, and then we're going to change the units and we're going to tare it, because that 3.8 pounds is not 3 pounds 8 ounces, it's 3.8 pounds. So now we're going to add 3.8 pounds of extra refrigerant, and then that'll be our total charge, including the flooded charge. All right, we are fully charged. We got our 3.8 pounds of extra refrigerant in there, so now we're doing a pump down test. I front seated the receiver's king valve, and we're just gonna run this guy, make sure it pumps down, the head pressure doesn't go too high, and then we'll open it back up and start putting everything together and watch the box come down to temp. Yep. It was pumping down just fine, so I didn't even let it go all the way. I saw it come down to about 32 PSI. The high side was dropping, so like, okay, we're good. So now we're just opening this up. We'll back seat it. We'll take the gauges off, watch the box come down to temp. We gotta let the system run for a day or so, and then we'll come back and check evaporator superheat because it's pretty warm in that box. So another thing to talk about too is saturation temps. So we're gonna run probably a little bit lower than normal saturation temperature on this right now, because this equipment was designed for the higher ambient conditions. It's like 50 degrees outside right now. So this compressor has a lot more capacity available, and it'll throw off the system's TD because it's a giant compressor in the wintertime, right? And then in the summertime, the capacity drops as the heat outside rises, and the compressor, you know, starts operating a little bit better. So you'd be closer to design TD, which, if I had to guess, I didn't design the system, but if I had to guess, the design TD balance between the evaporator and condenser is probably like 13 degrees or something like that. But we probably won't even hit that or be able to hit that right now because it's cool outside and we have a lot of available capacity from the compressor that's not operating in a high ambient condition, if that makes sense. So when you see lower than normal saturation temperatures, it can be a lot of things, but pay attention to what the compressor was designed for too. There's no capacity control because this is a fixed speed compressor, so it's running at the same speed all the time, whether it's hot outside or cold outside. We do have a head pressure control valve, but that's not going to bypass till 148 PSI. You know, they're floating the liquid temperature way down to try to make it more energy efficient, and that's just, you know, something that happens on these systems. I think that the answer to this is more digital scroll compressors, more capacity control, but you know, that's not happening on the light commercial side as of yet. All right, we are put back together. Everything's good, bolted down. Life is good on that one. We're gonna go downstairs, check the box temp. We just gotta get the rest of this stuff off the roof. All right, let's have a look back here, see what the temp control says. It's about to satisfy. Temp control says 39. Coil looks good. We got it all taped up and foamed up there. Drain line's good. TXV looks good. Nice even frost pattern coming out of the feeder distribution tubes. All right, I'm happy with this. We're gonna put the panels on, and like I said, we'll come back in a couple days and do a check superheat, make sure all that's good. But yeah, this is good and good. Good to go.
Wasn't too big of a deal. You know, when we have jobs like this, I've got multiple people doing multiple things. So, you know, we all kind of stick to our tasks. So Leo, you know, his job was to remove the old equipment, to do the drain lines, to hook up the electrical at the evaporator coil. Will's job was working on the roof. He handled the condensing unit, the line set on the roof, connecting it up there. And then I handled the attic work. So I was up in the attic running the new line set, connecting it, utilizing the certain section, you know, routing the electrical, doing all that stuff. We had Robert outside, you know, kind of being the go-between, you know, recovering the refrigerant from the old condensing unit. So we have kind of a routine that we all get into, and we all kind of know what our jobs are. This is something that we discuss, so we have a game plan before. Everybody knows, hey, this is what you're going to be doing. This is what you're going to be doing. And that's kind of how we, handle these jobs. Now, it's not always that we get to have 4 people. Well, we had 3 people working. Robert was recovering and things like that. But I mean, 4 people working on a job. It doesn't always work that way, but it certainly makes the job go faster. But it only makes the job go faster if 4 people are actually working, right? In the beginning, when we were still kind of all getting used to each other, these jobs took a little while because everybody was trying to figure out what to do, how to work with each other. But, as we've worked together and become a team, it makes things a lot easier and these installs go a lot smoother, basically. Okay. It's a struggle for me because I like control, right? And I like to control things, but I've realized over the years as I've gotten older, I have to let go of that control and I have to let people make their own mistakes and learn from them and grow, because my sanity is on the brink of non-existence. So it's like I have to learn to kind of let people just do their thing and trust in the fact that they know what to do because we work together and they understand my expectations and the way that things need to go. And that was a struggle at first, but it's been getting a lot easier over the last couple of years because I have a good team behind me. And, again, we work together. So when it comes to these jobs, little things like I don't want to have to bring the recovery equipment on the roof. We could, it's no big deal, but that adds more time because if we have to recover the refrigerant from the condensing unit on the roof, well, it's not ready to go when the crane shows up. Literally we got to this job about 45 minutes before the crane. That wasn't enough time to get everything disconnected, recover all the gas, lift the unit off, and be efficient. So what we did was pump down the condensing unit, slam the gauges inside of it, and the crane showed up, and boom, we lifted it. We waste no time. I want to get that crane operator out of here, just in and out of the place. The least amount of time with a boom in the air, the better, because there's just less chance of bad things happening. Less chance of people walking underneath the boom, something falling off the condensing unit, that kind of stuff, right? There's a lot that goes into safety, and you don't necessarily see it all when I film a video like this, but again, teamwork, right? We communicate with the crane operator. Now, this particular crane operator, I know this guy really well. I trust him. He understands the signals. We know what we're doing when we talk to him. We all kind of vibe together, and it's a great relationship we have, business relationship we have with this particular crane operator. Now, I work with some other crane operators sometimes too, and sometimes it could be a bit frustrating. But when you can get the good people, use them, right? Even if they cost a little bit more money, it's worth it. So going through the routine, everybody has their own stuff to do. It makes it really easy because then, I can just pick a task and it's like, hey, I'm going to work up in the attic and I could do that. Now, working in the attic is its own struggles because you don't want to have to get up and down. Getting up and down from the attic is just, it makes you exhausted at the end of the day, right? You just feel beat down. Now, even this, I felt beat down at the end of the day because it looked like we had a lot of space, but it was kind of awkward the way that I was having to braze and everything, but it is what it is, But I just try to be as prepared as possible. So I brought up all the tools that I thought I would need. Now, I was missing a few things, like I didn't bring a mirror up, okay? So what you didn't see was I mentioned that it was difficult brazing blind, right? Brazing blind to me is meaning that you can't see all sides of the braze joint. So you're just doing it from the top, and because the fitting was cleaned before, deburred before, you just assume with the way that you lay the solder on there and you heat it that the solder is going to flow all the way around the pipe. Now, in this situation, I didn't bring a mirror up with me. That was like the one thing that I forgot. So I turned my camera on, put the flash on, and used my camera on video camera mode to go around the braze joints because I'm a nut and I have to inspect every braze joint with my eyes to be sure. Okay. I'm confident in my braze joints, but still it's like a superstitious thing. I have to inspect every braze joint with my eyes. So usually getting in there with a mirror, this time I just use the camera and my phone, right? again, the teamwork that moves through these jobs, right? So I'm up in the attic and Leo's down inside the box and we're communicating back and forth. Now, sometimes we're talking through the box. There wasn't a lot of noise in this environment, but sometimes we have to get on our phones, right? So we carry Bluetooth devices with us. We can have conversations. We'll get on, you know, three-way calls or whatever with multiple people. Like, let's say when we're running a line set, we usually have 2 guys on the roof, 1 guy in the attic and 1 guy down in the box. The 2 guys on the roof are doing something and we'll get on a big 3-way call and we'll all communicate back and forth. Those are all little things that can help, because there's nothing worse than a guy up on the roof trying to feed a line set down through a hole cut in the roof, and then someone down in the box screaming one thing. Nobody can hear each other. It's all about communication. So I like using my phone, a Bluetooth device. I personally don't want 2-way radios because you got to click the beep beep button, and I'd rather be able to use my hands and do what I have to do. When it came to evacuation, pressure testing, all that went well, no big issues. Starting it up, everything was good. And we got it operational. You saw it come down to temp. We did come back about a week later, checked on the box, made sure they had no issues. Everything was good. No ice and, no ice present or anything like that. We also checked the evaporator superheat. Will came out there. Everything was good. We didn't even have to make any adjustments on it. So all was well. This turned out to be a nice job. Again, customer supplied equipment. But, it is what it is. We're thankful for the work that we have. So I really appreciate you guys making it to the end of the videos. Thank you so very much. If you haven't already, please consider checking out my website, hvacrvideos.com. We have hats, beanies, sweatshirts. The sweatshirts right now, we have them heavily discounted because we're trying to clear out inventory. So we dropped the sweatshirts. They're zip-up hoodies down to $25. So within the United States, that includes shipping. $25, we'll send out a sweater. Now, unfortunately in Canada, because the shipping rates are so extremely high, the price of the sweater is still $25, but you got to pay that ridiculously high shipping fee. I think it's like 30 or 40 bucks or something like that for Canada. And that's just, it is what it is. We just eat freight costs going to Canada. It's just nuts how much that stuff costs. So, but yeah, check out the website. Lots of great merchandise on there. It's a great way to support the channel. A couple other ways to support the channel if you're interested in doing so. The easiest way actually is just watch the videos from beginning to end. That really is the easiest way. You can also support the channel via PayPal, Patreon, and YouTube channel memberships. Those are all different methods that you can support the channel financially on a monthly basis through like YouTube, Patreon, those different things. There's links in the show notes of the videos if you're interested in that. Another really cool way to support the channel is by going to TrueTechTools.com. I have an offer code set up with them. Big picture, one word. If you use that offer code at checkout, most of the items on their website, you'll get an 8% discount. Now, there's a few items that discount code doesn't apply to, but when the discount code does work, I get a small commission from that. So it's a great way to help support the channel. You get the tools that you need. And I just love True Tech Tools anyways. They're great people over there. That's it. That's all I got for you. Thank you so very much. I really do appreciate you, and we will catch you on the next one.